Hey, yo, what's up? Welcome to this video. This one is paper 2-1 of May-June 2014, and this one is also a requested question. Now, with that being said, let's move on to the questions. So the first one, what do we have? So here we have to find the set of values of x for which this is true. So we have done this kind of question many times before. So let's see how do we proceed. Now we have this here, we have this here. So let's send everything to one side. So let's first expand this. You will have x squared plus 2x, send this over here, becomes minus x less than 0. Simplify, you will have x squared plus x has to be less than 0. Now, whenever we have this kind of question, we try to first find the critical values of x. So, critical values of x is just the same equation, but we change this to equal to 0. Now, we can solve this by factorization. So, x is common. That will be x plus 1. So x can be 0 or x can be minus 1. Now again, this is not your answer for the question. We have to use these values on the graph. This is your value of 0. And because the coefficient here, it is 1, it is positive 1, the shape of the graph will be something like this. Right. Now these 2 points are called the critical values. This is minus 1 and this is 0. Right. Now we're looking for the values which is less than 0. So below this line. So it will be between those two. So that's the main idea behind this. So we conclude that x has to be less than minus 1 and 0 between that value. So x between minus 1 and 0 for this one to be possible. Now let's move on to question number 2. So without using a calculator, express this in the form of a plus b root 3, where a and b are integers to be found. Now integers are just whole numbers, can be negative or positive whole numbers. So one by one, let's see what do we have here. So what do you think about this? For example, let's say we had a power minus 2. Now by the laws of indices, we know this is also equal to 1 over a squared. So that's the same idea we're going to use here. That will be 6 over 1 plus root 3 square. Now we can first simplify the base. We can expand. That will be what? That will be 1 plus 2 root 3 and plus 3. So that will be 4 plus 2 root 3. So let's rewrite this as 6 over 4 plus 2 root 3. So now we have to simplify this. So we have to multiply by its conjugate. That will be 4 minus 2 root 3 and 4 minus 2 root 3. So let's see what happens. So the top will become 24 minus 12 root 3, and the base will become 4 square minus 2 root 3 square. Because we do realize that here, if you look here, what do we have? We have a plus b times a minus b, which is basically the difference of squares, as we have seen many times before. So that will be 4 square minus 4 times 3. So let's do that. So the top will be the same for now, don't change, and the base we have to simplify. That will be 16 minus 4 times 3, that will be 12. So in the end, we can take out the value of 4 here outside. You will have 6 minus 3 root 3 over the value of 4. Now, in the end, simplify. Here you go. 6 minus 3 root 3. Okay. So this is your answer for question number 2 in the form of a plus b root 3, where a and b are integers to be found. So I guess the main point here is we had to understand we could express this in this form, and then we had to simplify this into this, and then multiply by its conjugate, so by the whole fraction, because you don't want the fraction to change. That's why you have to multiply by the same thing at the base as well as the same thing at the top, so it doesn't change. Now we have to simplify step by step, and then you will find this as your answer as required by the question number 2. Question number 3. So on the axis below, we have to sketch the graph of this, showing the points where the coordinates of the points where the curve meets the x-axis. That's the main thing right now. Now again, as we have seen before as well, so the first thing I like to do is first ignore the modulus sign. So let's first assume our curve is y equal to x minus 4 times x plus 2. Now on the x-axis, what do we know? We know that at the x-axis, the value of y is 0. So replace back in the equation, you will have the equation here equal to 0. That will lead to x equal to the value of 4 and x equal to the value of minus 2. So let's first mark those 2 points. So it is only a sketch. We don't need to be exact. For example, I can say 4 is somewhere over here. Why not? And minus 2 should be somewhere, let's say, around this point, if that makes sense. Right, those 2 points. So now we don't need to mark the coordinates. We can just show the points where they cut the x-axis. Now the next step is, as we can see, this one is what is that kind of graph? If you were to expand, you will have what? For example, let's see. Why not? Let's check it out. We'll see what do we have. If you expand, you will have x squared minus 2x minus 8. Right? If you expand this, you will have something like that. Right? So this one is clearly a quadratic equation, which means you will be having this shape or this shape. Right, now because this is a positive 1, right, so it will be this shape, not this one. Okay, so now we know we have a shape like this. We have to find the minimum point of this graph. So how do you find the minimum point? There's many ways. So one of the ways, as we always use, is using dy by dx. For example, we can say let's find dy by dx. Why not? So dy by dx, of course there's no need, but hey, we know this method, why don't we use it? That will become, so that will become 2x minus 2, right? So 2x minus 2. And then of course we have to equate to 0, because at the minimum point, dy by dx is equal to 0. That's something we have to know to solve those kind of questions. So x have to be the value of 1. So value of 1 should be somewhere over here, right in between. Now, what is the corresponding value of y when x is equal to 1? Replace back in this one, because right now we are assuming that it is not, there's no modulus. That's the first step, right? So x equal to 1 will be 1 minus 4 times 1 plus 2. That will be minus 9. Minus 9 should be somewhere, let's say, over here. So this should be right here. So this is minus 9. Okay, so the first step is to do what? The first step is to pretend you're drawing this curve without the modulus sign. For example, you will try to connect this. Because you know the shape should be something like this, so that's why we can safely assume it will be from up going down, right? So that will be this. This way, and then try this one. Here you go. So that's the first thing that we can do. Now we know that everything. So now if we go back to the main question with the modulus sign, the modulus sign means that everything below the x-axis will be reflected upwards. So it means that this point right here will be reflected onto the opposite side. That will be the point 1, 9. 1, 9 should be somewhere over here. Now this will be your answer. This is the actual answer. That should be this part of the curve is up. We stop here. And we have to reflect this up. That should be maximum point now. That should be this side. And this should be this side. And this is the other side of the curve. Now obviously you will have to erase this part of the graph because that is not part of the answer. Okay, as you can see, the first step is to first ignore the modulus sign and then find where it cuts the x-axis and then draw the curve, basically know what shape the curve is according to the equation, and then we can find the minimum point, draw the curve, pretend to draw the curve, and then just switch everything which is below upwards to find the modulus answer for this one. And that is your question, part 3.1. Now for part 2, we have to find the set of values of k, for which this is what? This is the graph that we have just seen, which is y has to be equal to k, has 4 solutions. So very easy. The thing we are thinking about here is that, first thing, how would you draw a line y equal to 1? It will be a horizontal line at the value of 1. Same thing here. The idea is, if you were to draw a horizontal line on this graph, where would you have 4 points of intersection? So 4 solutions mean 4 points of intersection. For example, let's try. If I draw my, let's say if I draw my line here, I will have 1, 2, 3, 4, which is good, right? Now if I draw my line here, 1, 2, 3, 4, it is still good. But what if I draw my line right here? So this is pass, obviously. This is, it will always continue up, right? But now if you count, we have only 2, so this is not good anymore. What if I draw my line here, passing at the maximum point, have only 1, 2, 3, so not good, not good. This is good, good. And what if I go here on this x-axis, so we only have 2, which is not good. Now you can see the range, the value of k can take is between those two, right? Anywhere between those two, we can take the value of k, for which my equation will have 4 points of intersection. So we can say k can be the value between the value of 9 and this. So according to the graph, that will be this as my answer. So k has to be between 0 and 9. So I hope that makes sense. The main idea is that you have to know first what solution are you trying to solve. Basically here we see that it is a horizontal line, right? Now we have to see where it has 4 solutions. So we draw a line, we see, okay, this is still fine. We have 4 points of intersection, which means 4 solutions. Now we keep going up, this is still okay. But what if we go up to the maximum point? We have only 3 now. It is not 4, it is not good anymore. Now let's try down. We go down, it is fine, fine, fine. Oh, until here, it is not fine again. So it means that the values of k can only be between those two lines. So the range of k will be between 9 and 0. This is how you would find the answer, by using the graph you have drawn in part 1. Okay, so now let's move on to question number 4. So here we have an expression, this. So let's first call this, let this be f of x. Has a factor of this. So factor means there's no remainder. So we use the remainder theorem. What is the value of x? So x minus 4. Equate that to 0. Let's see what happens. So x will be the value of 4. So it means that if f takes the value of 4, the remainder is 0. This is given by a factor. So whenever you have a factor, it means that the remainder will be 0 if you take in the value of this. Now same thing applies here. It will have a remainder of minus 12 when divided by this one. Now same steps. What is the value of x? So x minus 1 equate to 0. X has to be 1. Now if f of x takes the value of 1, the remainder is now minus 12. As you can see, we have 2 equations that we can use to find the values of a and b. So let's do one by one. First one, put the value of x here, replaced by 4. That will be 2, 4 power 3, plus a, 4 power 2, plus b times 4, and plus 12. That will be 0. Now simplify. 4 power 3 times 2, that will be 128. That will be 16a plus 4b plus 12. And that has to be 0. Now simplify, that will be 16a plus 4b plus the value of 128 plus 12, that will be 140 equal to 0. Now let's send this to this side. You will have 16a plus 4b has to be minus 140. Now let's see if you can divide by 4 everywhere. Divide by 4 everywhere. Let's check, right? Is that possible? Because we can see here we have 16, here we have 4, here we have 140. Let's check if that's possible. Here we have 4a plus b equal to minus 35. So let's make b become the subject. B will be minus 35 minus 4a. Okay, that will be my equation number 1 to solve for the value of b and a. Now moving on to part 2 now for this one. Replace the value of x by 1. You will have 2, 1 cube plus a, 1 square plus b times 1 plus 12 have to give you the value of minus 12 according to the question. Now let's solve. You will have 2 plus a plus b plus 12 has to be minus 12. Now a plus b has to be what? Minus 12, and minus 2, right? So a plus b has to be minus 12, minus 2, that should be minus 26. Okay, so that will be my equation number 2. Okay, so let's solve now. Pretty easy. We have 2 equations. We can solve simultaneously for the value of a and b. We place b in here. So you have a plus b. B is also equal to minus 35 minus 4a. And that will be minus 26. Now simplify. A minus this will be minus 3a. Minus 26, we send this over here, become plus 35. That will be 9. So a has to be minus 3. From this, we can find the value of b. So b has to be minus 35 minus a times minus 3. So minus 35 minus 4 minus 3. That will be minus 23 for the value of b. Okay, so that will be your question number 4. You just use the information given to you by the question, follow step by step. This one is pretty easy, I believe, and then you can just solve for the values of a and b. Now let's move on to question number 5. So here we have to express this in terms of this, where p and q are constants to be found. So pretty easy. The first step is we have to check for the coefficient of x squared. Sorry, here we have 2. In this case, we have to find a way to change this into 1. So, but first, what I'd like to do is I'd like to rewrite this down. I will have 2x squared minus 1, some space, that will be plus 6. Now, I have to find a way to take this outside, so factorize 2 outside. That will be x squared minus 1 over 2x and plus 6. Okay, so next step, because now the value here is 1, we can continue to the next step. So that's the first thing we need to make happen for it to be possible. Now that will be 2. Here we have x squared minus half x. And now we have to add a value. The value will be, this value right here will be half and divide by 2 square. Now again, when you add a value, you also have to minus the same value so you don't change the equation. Now, because this was inside of the bracket of 2 here, you also have to give it 2. That makes sense, right? Now simplify. This 2 will be 2 here. This will become x. Minus sign will be minus. Here inside you will have 1 over 4. And here we have a square, that will be square. Here we have 6. So we have 6 minus 2 times 1 over 4 square. That will be 5.875. So let's double check one more time, because you would not like to make any silly mistakes. 1 over 4 for the value inside, square, times 2, and 6 minus the answer will be this. Okay, good enough. So finally, we can rewrite this down as, this is 2x minus, this is 0.25 square plus 5.875. So we have shown this is p, q, and r are constants to be found. This is part 1 of the question. Now for part 2, hence, so whenever you see hence, it means we have to use this answer to find the least value of this and the value of x at which it occurs. So pretty easy. So the idea is that when you change the function to its complete square form, the value at the end will be the stationary value. And the reason why this is the least value is because of this here. It is plus 2, right? The coefficient of x squared is plus 2. Because of that, the shape of the graph will be something like this. So just to recap, something we must know. Let's say I have x squared minus 2. So because the coefficient of x squared is minus 2, it is negative, the shape will be like this. Okay, so that's something good to know when dealing with those kind of questions. And we can just think fast to find out what can we do to find the answers. In this case, we know the shape is like this, so it means that it will have a minimum value. Now, by converting this to this, we know that the n value here, this one, the value at the end is called the minimum value, and it happens when this here equals to 0. That's the trick, you know. Whenever you convert your function to p x this square plus r, the value at the end here, r, has to be the stationary value. Okay, and the value occurs when this equals to 0. So that's the main thing you have to remember when dealing with those kind of questions. So this is the least value, and the value at which it occurs will be x minus this equate to 0. So x will have to be 0.25 as your answer. This is question number 5. Okay, so let's move on to question number 6. So here we have to find the coefficient of x power 5 in this expansion. So pretty easy, one by one. So how would you expand this usually? So you would say you will have power of 8, you will have 8 combination, something we don't know yet. And then here we have 3. Here we have minus 2x. Now for it to be something in x power 5, we understand that we have to put 5 here because we want that term. If this is 5, this also will be 5. 8 minus 5 is 3, so this will be 3. So this is just a formula we have to know how to use this to find these values. Now let's see. 8 choose combination 5 will be 5, 6 times 27 and times 1. So minus 2 power 5 should be minus 32, and that will be x squared. So simplify 5 6 times 2 7 times minus 32, that will be minus 48 3 84 x squared. However, the answer has to be only the coefficient, which is this one, will be the answer, which is minus 48 384 is the answer for part A. Now for part B, we have to write down the first 3 terms of the expansion in ascending powers of x. So pretty easy. Same thing step by step. We have to expand this. That will be 6 choose 0, 1, 2x. That will be 0 here, and that will be 6. 6 choose 1, that will be 1. 2x, that will be 1 here, that will be 5. And 6 choose 2, 1 here, 2x. We have 2 here, that will have to be 2 here. 6 minus 2 is 4. This is the first 3 terms of this expansion. So this will be 1 times 1 times 1. 6 times 1 times 2x. And what is 6 combination 2? That will be 15 times 1 times 4x squared. So simplify, that will become 1 plus 12x plus 60x squared. So this is the first 3 terms of this expansion in ascending powers of x, from small x to big X in terms of powers. Now for part 2, in this expansion, so we have this and multiply by this one, right? The coefficient of x squared is this, is 1.5 times the coefficient of x. Find the value of a. Now again, according to the question, we only care about the coefficient of x squared and the coefficient of x. Now first thing, let's pretend we are expanding this. You will have what? 1 times 1 plus 2x, this, and plus ax times 1 plus 2x power 6. Now, let's replace the values here for the first 3 terms. Obviously, we have to use what we have before to help us. That'll be 1 plus 1, 12x, plus 60x squared, plus ax times 1 plus 12x, plus 60x squared. So now we can simplify. We have to find the coefficient of x squared and the coefficient of x. So we need 1 times this and 1 times this, because this is x and x squared. You will have 12x plus 60x squared. And for this one, because here we have plus, we can put plus. Here we have this, we need to multiply by this and multiply by this, because we need x and x squared. That will be ax plus 12ax squared. Now simplify, what do you have? Here we have x, combine them together, you will have 12x plus ax. Then here we have plus 60x squared plus 12ax squared. Now we can try to factorize, because here we have x, which is common. X outside, you will have 12 plus a. And here we have x squared, which is common. That will be 60 plus 12a. So now we have to look at the question that is given to us. The coefficient of x squared, that will be this. So 60 plus 12a is equal to 1.5 times the coefficient of x. So this is the equation we get finally to solve for the value of a. So let's simplify. That will be 60 plus 12a equal to 1.5 times 12, that should be 18, plus 1.5a. So send a to one side, you will have 12 minus 1.5, that will be 10.5a, and that will be 18 minus 60, that should be minus 42. So a has to be this divided by 10.5, that should be minus 4. Okay, and this will be the answer for question number 6. Okay, here we have question number 7. So let's see, here we have some differentiation and also stationary values. So let's do one by one. So first thing first, we have a curve, have equation y. This is given to you. Now, the one thing we can do right away is we can rewrite this equation to help us out. We can see that y can be equal to x power minus 1, right? And here we can have 2x power half, right? Now it is much easier to find the values of dy by dx. So let's do that. This will be dy by dx. First thing, we'll have to multiply by the power. That will be minus 1 multiplied by. Then we have to minus 1 to the power become minus 2. Same thing here. Here we have plus, but we have power of half. That will be half. That will be 2 here. And we have to minus 1. That will become minus half. So you will have, in the end, you will have minus this value. Here, this cancel. So you will have plus x this, if that makes sense. So you will have minus 1 over x squared and plus 1 over root of x. This is dy by dx. Now we have to follow up with this to find the value of d2y by dx2. So we have to use this one. It is much easier to use this to find that value. So again, same thing. First multiply by the power. So here we have minus sign, which is minus 1. Multiply by the power will be minus 2. Then minus 1 to the power, which will become minus 3. Now for this one, same thing. Here we have plus, but first multiply by the power. That will be half. Here we have this, and here we have minus 1 become minus 3 over 2. Right. Let's see, simplify. That will become 2 here. That will become x over 3. X power 3. And here we have minus sign. This will be half 1 over 2. And this will become x 3 over 2. And this is dy by dx2. Okay. Now for part 3 of the question, hence, so whenever you see hence, it means you have to use the answers from part A that we have to find the answers below. So we have to find the coordinates and the nature of the points. So pretty easy. As we know, at the stationary value, we have to know dy by dx have to be 0. Now we have seen that dy by dx is given by minus this over this, 1 over this have to be 0. That's the first thing we have right now. So we have to solve this to find the values of x and then hence to find the point and then eventually the nature, but one by one. So let's see what can we do. So let us rewrite this. So we can have minus 1 over x squared plus 1, that will be x half. So one thing we can do is, if you want to eliminate the denominators, we can first try to multiply. So let's do something simple. Let me send this over here. Here it is negative, let's send this over here. That will become what? That will become 1 over this has to be 1 over this. Okay, so we have this now. So now we can try to simply cross multiply. So you will have x squared on one side, and this is x half on the other side. Okay, now again simplify. You will have what? Send this over here. You will have this minus this is 0. Okay, so what's next? So we have to find a way to simplify this equation. For example, here, because we have the power of I guess it is easier to explain this over here, because we have those powers in like 2 and half. It's kind of hard to work with, right? But the main idea we can use here is that we can continue here. We can just square both sides from here. Let's forget about this step. Let's do this here because it is much easier to understand. If you square both sides on this step, you will have what? You will have x power 4, that will be x. That makes sense, right? Because here, I don't want to confuse you guys. Let's not take this step. Let's just continue from here. Square both sides, you will have this. Now we send x over here, you will have x power 4 minus x is 0. Now what I can do, I can factorize. That will become x power 3 minus 1 is 0. Now simplify. That will become x is equal to 0 and x 3 minus 1 is equal to 0. So here we have this, my first point, and this I have my other point. So x have to be the value of 1. This is my two x values for my stationary points. Now let's find the corresponding y values. To find the y values, we place back in the main equation. So let's see what happened. So now let me write down the equation of the curve. Y is equal to 1 over x plus 2 root x. Now as you can see, because of the domain here, x has to be more than 0. We cannot take this point. It will not be possible, right? Because x is 0, it is not valid for this equation according to the domain given to us. So we can only have this one point to use. So let's do that. So x equal to 1 will be y 1 over 1 plus 2 1. That will be 1 plus 2, that should be 3. So the stationary point is eventually equal to 1 and 3. Now we have to find the nature of the point. To find the nature, we just use d2y by dx2. So let me continue here with a different color, of course. Let me use black. The nature, we have to find the value of d2y by dx2 at the value of x equal to 1, right? Let's use that. So replace, you will have 2 over 1 minus 1 over 2. That should give you 3 over 2, which is a positive value. Now you can write, since d2y by dx2 is a positive value, we conclude that the nature, which is the point, the stationary point, is a minimum point. So that's the nature of the point by using d2y by dx2 at that point when it happens. So I think the only tricky part here is to try to solve this equation. But as you can see, it is always step by step and thinking, how can you simplify this? But either way, let's say you guys did not know how to square both sides. You did this. So what could you have done here? You would do the same thing. You will factorize, because we know that what is 2. So for example, if I take out the value of half, right, you will have x 3 over 2 minus 1. Right. So eventually that should also give you the same answer. So that's the other way you can also do this. You will have the same answer for that stationary points and the nature. And the main point is when you see hence, just use the previous answers to help you find the answer for the third part. Now let's move on to question number 3. So here we have a sector of a circle of radius r has an angle of theta radians, where theta is less than this. This is 180 degrees. Now, the perimeter of the sector is given by 30. Okay, so part 1, we have to show the area A is given by this. So one by one. So first thing, let's see, what is a sector? For example, let's say this is my center. A sector could be a shape like this of a circle. Right? It will be somewhat like this. We understand. This is the radius, and this is the arc. How would you find the length of arc? As we have seen before, it is equal to r times the angle in radians. This is the angle for the sector. Now, we know the perimeter for the sector is 30. So how would you find perimeter? That will be the distance around this shape. That will be r plus theta and then r. That should equal to the value of 30. Now simplify, that will become 2r plus r theta is equal to 30. Now let's just keep this like this for now, for part 1. But the question here is we have to find the area of the sector. Now, as we know, area is given by the equation half r squared theta. Now, the one thing we realize now is that, hey, you know what? We have to show this equation where we don't have any theta. So we have to find a way. How can you eliminate this theta? So we have to use this. Let's make theta become the subject of formula. You will have r theta has to be 30 minus 2r, and theta has to be 30 minus 2r divided by r. So replace the theta back in the main equation. So you will have half r squared times theta. That should be 30 minus 2r over the value of r. That will be going away. And let's see, what do we have now? We will have 30r minus 2r squared over 2. So finally simplify, divide by 2. A has to give you the value of 15 minus r squared. This is shown as required for part 1. Okay, now for part 2, given that r can vary, find the maximum area of the sector. So how would you find the maximum area? So that will be happening at dA by dr equal to 0. If that makes sense. So whenever you have to find the maximum area, the minimum area, or the max or mean value, we have to find the derivative by differentiation. So let's do that here. So dA by dr has to be 15 minus 2r. Equate that to 0. So 2r will be 15, r will be 7.5. This is when it occurs. So the maximum area occurs when the value of r is equal to 7.5. Now for the area, replace that value back in the equation for area. That will be 15 times 7.5 times 7.5 squared. 15, 7.5 times, so minus 7.5 squared. That will be 56.25. That will be centimeters square for the maximum area of this sector. And that was question number 8. Okay, so let's move on to question number 9. So solutions to this question by drawing will not be accepted. So basically you have to show all your calculations step by step to get your full marks. So here we have the points A, B, C, and D, where P and Q are constants, great, are the vertices of a kite of A, B, C, D. Now first thing first, let's draw a kite. So kite will be, let's say the shape will be somewhat like this. So we don't need to be accurate, we just need to have an idea of what can the shape of a kite be. So it will be, so for me I would say somewhat over here, not good. Let me find a ruler. Okay, so let me use that so I can have a at least half decent Kite. So let me measure this value. 1.5 should be here. So let me join that. So this will be join with this, join this with this. So the main idea is that whenever you have something quite complex without any drawing, you can also make your own drawing to help you find the answer for the question. Now again, you're not using that to find the answer. You're just using this as an indication to hence use calculation to show the answer, right? So that will be A, B, C, and D. Now what else do we have? It says the diagonals of the kite, which is the vertices joining together, this and this, they will meet at, which is AC and BD, they intersect at the point E. So this is my point E. Okay, good to know. And then we have the line AC. It is perpendicular to, it is the perpendicular bisector of BD. Okay, so we have to understand what is the meaning of perpendicular bisector of BD. It is a line. So basically AC is a line that goes through the midpoint of DB at the angle of 90 degrees. That's what it means. So that's the first thing we need to understand. What does it mean to be a perpendicular bisector? Now let's move on to the questions. So part 1, we have to find the point E. The point E is this point. So basically the point E is the midpoint of D and B. So D is 5, 4 and B is 1, 6. So E is the midpoint. That will be 5 plus 1 is 6 divided by 2. So 5 plus 1 divided by 2. 4 plus 6 divided by 2. So this is just a formula we use to find the midpoint of 2 points. For example, let's say we have the point A, which is x1, y1, the point B, which is x2, y2. So we don't know the points. The idea is that the midpoint have to be x1 plus x2 over 2 and y1 plus y2 over 2. So same thing here, replace those 2 points. So that will be x1 plus x2 over 2, y1 plus y2 over 2. So that will give you what? 6 by 2, that will be 3. 10 by 2 will be 5. So this is your point A, which is 3, 5. Now for part 2, we have to find the equation of the diagonal AC. So we have to find the equation of AC. So how can we find that? So as you can see, AC is a straight line. Okay. Now to find the equation of a straight line, we must first find the gradient of AC. Right. Now to find the gradient of AC, we can first use the gradient of dB because it is easier to find this than this. So we can find this, then we can derive this. Because we know the points D and B already, we can use them to find their gradient. So D is 5, 4 and B is 1, 6. So the gradient of dB, that will be y2 minus y1, that will be 6 minus 4 over 1 minus 5. That will be, the value is 6 minus the 2 over the value of minus 4, that should be minus half. Yeah, that makes sense, right? Now, from this we can derive the gradient of AC have to be the value of what? Of 2. Because, why? Because the line AC and DB, they are perpendicular to each other. So we understand that because of that situation, we know that the gradient of AC multiplied by the gradient of DB has to give you the value of minus 1. So by using this equation, you can find the value of this to be 2. That's the first thing to do. Now to find the equation, we need a passing point. So the point C and the point this we don't know, but we know the point E, which is a passing point. So the point E was found to be 3, 5. So let's use that to find the equation. That will be x and y. So let's do, so y minus the corresponding value over x minus the corresponding value will be the gradient. Then we cross multiply, you will have y minus 5 is equal to 2x minus 6. So y will be 2x. Send this over here, that will be minus 1. Right? Minus 6 plus 5 is this. So in the end, we conclude that the equation of AC is y equal to 2x minus 1. Okay, that is part 2 of the question. Let's move on to part 3 of the question. So here we have to find the area of the kite. As you can see, we have the point A. A is given to you by P1. B is given by 1, 6. C is given by 4Q. And D is given by 5, 4. Now before you find the area, you have to obviously find this and this value. Now again, since we know we have the points A and C, and we know the equation of AC from part 2, it was found to be y 2x minus 1. So let's find the value of P and Q. So for this one, this is the x value and the y value, x value and the y value. So let's look at this one first. When x equal to P, y is equal to 1. Replace, you will have 1 here. 2 times P minus 1. 2P is 2, leading to P has to be 1. So A is a point 1, 1. Now see here, same steps. When x equal to the value of 4, the value of Q of y is Q. Same thing. Replace, you will have Q, that will be 2 times 4 is 8, minus 1, that will be 7. So the point C is 4, 7. Now, since you have all the points, we can easily find the area. We have many ways of doing so, but one of the easiest ways I find is using the array formula method, which is equal to half modulus of the first point is 1, 1, 1, 6, 4, 7, and then 5, 4. Now, when you begin with a point, you have to end with the same point. Okay? Now, we first multiply in this direction. That will be half. 1 times 6 is 6 plus 7 plus 16 plus 5. Then minus, we have to multiply in this direction now. That will be 1 plus 24 plus 35 and plus 4. Let's simplify to see what happens. Obviously, it's always best to use your calculator. That will be 6 plus 7 plus 16 plus 5. That will be 34 minus 1 plus 24 plus 35 plus 4. That will be 64. That will be inside the modulus sign. That will be minus 30. Now again, for the values inside of the modulus will become positive. That will be 12 times 30. And that will give you 15 units square for the area of the kite. So that is one way of finding this. First, find all the points that you need to find, and then using the points to find the area of the shape. And that will be your question number 9. So let's move on to question number 10. So here we have to find dy by dx, this one. So step by step, as you can see here, this one is a product. We have this multiplied by this. That will be what? That will be, so we use the product rule. So dy by dx, we can first leave the first one by itself, that is this one, don't touch it. Then multiply by d by dx of this one, that will be cos of this, multiplied by 1 over 3. And then plus sine of x over 3, multiplied by d by dx of this will become minus sine 2x times 2. Right. So you will have 1 over 3 cos 2x cos x over 3 minus 2 sine 2x sine x over 3. Okay, and this is your answer for question 1. Now let's move on to part 2 of the question. So here we can see we have a fraction. So when you have a fraction, we have to use the quotient rule. So dy by dx in this case will be what? First, write down the denominator as it is. That will be 1 plus ln of x multiplied by d by dx of the numerator. That will be sec square x. Then minus the numerator as it is. Then multiply d by dx of the denominator. That will be 1 is obviously 0 plus 1 over x. And then in the end, you have to divide everything by the square of the denominator. That will be this, and we have this. Now simplify to see what happens. That will be 1 plus ln of x, this value, and minus tan over x, this, and divide by 1 plus ln of x square. Now you can leave this just like that, or if you want to simplify some more, you can do that as well. But that's the main idea. You have to apply the quotient rule to solve this question. Now let's move on to question number 11. So here we have to solve this. As you can see, this one is a indices question. So how can we solve this? The first thing we realize is that 64 is what? 64 is 2 power what? So 2 power 6 is 64. Right. Now here we have 1 over 64 is the same thing as 1 over 2 power 6, but it is also equal to 2 power minus 6. So let's rewrite this here. We have 2x squared minus 5x equal to 2 power minus 6. Now because we have the same base on both sides, we can cancel the base out. You will have x squared minus 5x plus 6 equal to 0. Simplify. Factorize those two, you will have x times x, and 6 is 3 times 2. To get minus 5, it has to be minus 3 minus 2. That will be x is equal to 3, and x is equal to 2. So these are the solutions for this equation. Now for part 2, by changing the base of this, express this as a single log to base a. So we have to basically make everything become base of a. So pretty easy. So log of 2a, 4, we can change that to log. So this is just the law of logarithms we have to know to solve this question. So let's change that. So we have to change to a base of a. Here we have 4, there will be 4 here. Here we have log base of a, and here we have 2a. Okay, so now we have this. Let's see what can we do to simplify this one. So also let's see something here. So what is this thing? So let's see if you can break this down, right? So we have log base of a, and that will be 2 times a, right? So which is the same thing as saying log base of a 2 plus log base of a and a. That's the same thing as this by the laws of logarithms. Now because we have the log base of a for the value of a, that is 1. So eventually we understand this has to be log base of a, value of 4, and that will be 1 plus log base of a 2. Okay, now replace in this. Let's see how can we simplify this. So in this equation we have this is equal to this, so log base of a 4 over the value of 1 plus log base of a 2 multiplied by 1 log base of a 2. As you can see, clearly these two are the same. Cancel out. So you will have log base of a 4. This is your question 11 for part A and B. Let's move on to question number 12. So I think this question we have done already. I would just combine the videos together for this one, for question number 12. So let's move on to the questions. So this one is a requested video again for a graph question regarding functions. So we have functions f and g are defined by those two. And here we have the domains of each function. Domains are the x values for which the functions are defined. Now part 1, we have to find f of g of 8. So when we have this kind of question, we can break it down. So first we can just focus on this one. Let's first find the value of g of 8. That will be g is here. Replace this by 8. You will have root 8 plus 1 that will become root of 9, that will be 3. Okay, so basically now we have to solve f, because we know g of 8 is 3, so that will be f of 3. And that will become, replace x by 3 here, you will have 2 times 3 over 3 plus 1. And that will become 6 over 4, and that will be 3 over 2, which is 1.5 as your answer. Okay, that is for part 1. Now let's move on to part 2. We have to find an expression for f square of x, giving you an answer in this form. Now something we have to know that f square of x is not the same thing as fx and apply square to it. It's not the same thing. So this is a tricky one, but it's pretty simple as well. So f square of x is actually f of x. So that's how we should find that value. So one by one, f of x is this, replace x by f of x. Okay, so you will have 2 f of x over f of x plus 1. Replace 2 times f of x will be 2x over x plus 1, then over 2x over x plus 1 plus 1. So now we have to simplify this fraction. So on top you will have what? You will have 4x over x plus 1. Now when you have divide, you can just change that to, so let's first simplify this. Make it easier for you. So on the base we have 2x over x plus 1 plus 1. So we have to make this become the same base. So basically same base will be x plus 1. That will be 2x plus x plus 1, if that makes sense, right? Then that will be 3x plus 1 over x plus 1. Okay, so basically here we have divide. We can change divide to multiply, and then we have to flip the function or the fraction upside down. So this will become x plus 1 over 3x plus 1. So as you can see, these two will simply cancel out, and you will have 4x over 3x plus 1 as your answer in this form, where a, b, and c are integers to be found, which is whole numbers to be found. So 3, 4, and 1 are whole numbers. That is part 2 of the question. Now for part 3, we have to find g inverse of x, stating its domain and range. Okay, so step by step, we know from the question that g of x is given to us by root x plus 1, where x has to be more than minus 1. That is g of x. Now, g inverse, we have to first let y equal to g of x. That will be this value. Now we have to make x become the subject of formula. So first thing first, have to send this over here. You will have square x plus 1. So finally, x will be y square minus 1. Now from this, we know that, what do we know? We have to write g inverse of x in terms of x. That will be, the value will become x squared minus 1. Okay, now moving on to the next question, we have to find the domain and range of this function. Something we can use here is that if you want to use, you can use it of course, but if you don't want to, you don't need to as well. It is up to you. So the range, the domain of g inverse is a trick that will usually help us. It is equal to the range of g. Or we know that, something else we know is that the range of g inverse has to be the domain of g. But here we know something already, which is this one. Domain of g is given to us by x is more than minus 1. However, if you want to write the range of g inverse, so the range is the vertical value, which is the y value. You can write y is more than minus 1, or you can write G inverse is more than -1. So this is the range of G inverse. Now for the domain, let's see what can you use. Right, domain, we have to look at the range of G. So looking at this of this function, to know the range we have to understand, sometimes I guess it's useful to understand the shape of the graph if you want to find the range. So you have to look at the shape of the graph of G of x. Now just to understand, for example, if you assume the value of x was -1, G inverse of -1 will be square root of 0, that will be 0. So let's draw the graph so we can have a diagram to understand. So we have your y-axis and we have the x-axis. That will be x and y. So when the value of x is equal to -1, the value of x of G is 0. It will be right here. So of course this is not equal to, so it will not be equal to this value. It will be more than this value, obviously. But for now, we're just trying to understand what is the shape of the graph. Now, as you know, as the value of x, so according to this function, as the value of x increases, we can see that root x plus 1 will also increase. But now it always helps to know how it will increase. If you observe, let's see, when the value of x is 0, the value should be 1. So 1 will be right here. And if the value of x is 2, so let's say 2, root of 2, that will be 1.41, should be somewhere over here. So as you can see, the shape is going to be somewhat like this. Right. So basically the idea is that by looking at the shape, we can confirm that the value, as the value of x increases, the value of y will increase. But most importantly, the y value will always be more than this value. So the range of G, which is G, has to be more than 0. Now again, we have to use this to find this. Now, your answer will be domain. How do you write domain? Domain you have to write in terms of x. So using this information, we can write down domain, it is x, has to be more than 0 as well. So this is domain, and this is range for your answer. So we have these two can be your answer for your range, and this is your domain as your answer for part 3 of the question. Okay, so let's move on to part 4 of the question. On the same axis, we have to sketch the graph of y equal to G of x and y equal to G inverse of x, indicating the geometrical relationship between the graph. So this thing you guys know, you must know at this point that we know the relationship between the graph and its inverse has to be a reflection in the line y equal to x. So that's something we have to know by now. So that's the main idea to show. But let me first show the line y equal to x. It will be a line going in between those two, so it should be this one. So I don't have a ruler, but it's always best to use one. As you can see, this will be my line y equal to x. So you can label this if you want to. That will definitely help. Now to sketch the graph, let's say we know that the graph of part 1, which is G of x, it is equal to root of x plus 1, where x has to be more than the value of 1. So as we have seen, let's label this as minus 1, not 1. This is the domain given to you by the question, right? Minus 1. So let's kind of mark the value here, minus 1. This will be 1, 2, 3, 4, 5. Now let's say if you do not know how to draw the curve because you don't know the shape of the curve, what can you do? In this case, what can you do is you can just make a table of values. For example, I can put x here and the value of G of x. For the value of, we know we start from minus 1, we can start here if you want to, and that will be 0, 1, 2, 3, 4, and 5. If you want to, you can go up to 5. It is up to you. Now let's find the corresponding value of g of x. Replace here, you will have 0, that will be 1, and root of 2, that will be 1.41, root of 3, that will be 1.73, root of 4, that will be 2, root of 5, 2.24, and root of 6, 2.45. As you can see, I am writing decimal numbers. It is not exact, but it's okay because here it is only sketch the graph, which we don't need to be exact to sketch. Okay, now we can label this line too. This axis can be 1, 2, 3, 4, 5. Now for g of x, the first point will be minus 1, 0. So this one, of course, you will not include in your answer, because as you can see, it has to be more than minus 1. So we cannot begin here, we have to be more, but we can plot this as a point, as a circle like this, where we don't include the value, if that makes sense. The next one will be 0, 1, will be this one. Then 1, 1.41, so 1, 1.41 should be somewhere over here. Then we have 2, 1.73, should be somewhere over here. Right, and then we have 3 will be 2, that should be somewhere over here. 4 will be 2.24, somewhere over here, and 5 will be 2.245, somewhere over here. So as you can see, it is only a sketch, so it's not perfect, but you have to try your best to make it a smooth curve. For example, let's try to connect them with a smooth line. So it will be somewhat like this. But of course, you will have to use a pencil, and then you will just adjust those points to wherever your curve goes through. At the end, you have to label this as g of x. That's my first curve. Now next one, since we know that the graph of g of x and the graph of g inverse is a reflection, we just have to copy and paste this, reflect this on this side. For example, this will be this one, this will be this, and this will be this, and this will be somewhere over here. So let's try to plot this as well. This one, somewhere over here, and that should be somewhere in between. So it's always best to reuse a ruler for this. It helps you to find the points as well. But you get the idea. You just need to be a reflection. Try your best as you can to join the points together. So that will be something like this. Okay, and of course at the end you have to label this as g inverse of x. Okay, and that will be your answer for question part 4 of 12 for graph question. So the main takeaway is this one. You have to show this relationship. And of course, if you don't know how to draw the curve, you can always revert to making a table of values and plotting points by points to find the shape of the graph. So this was question number 12 for Add Math. I hope this was helpful, and as always, thank you for watching. I will see you soon.